Let's have the first operation, which is the addition of functions. Let's define addition of functions. Let f and g be the functions with domains d sub f, that is the domain of the f function, and d sub g, which is the domain of the g function, respectively. The sum of the two functions f and g, denoted by f plus g, is the function defined by quantity f plus g of x, which is equal to f of x plus g of x. And we should get the domain of the sum of the two functions, which is the intersection of the domain of the f function and the domain of the g function. So let's have these 6 functions, which will be used all throughout the lesson on operations on functions, including composition of functions. Okay, so let's determine the domain of these functions. Looking into these functions, f function, g function, and m function, they are under the polynomial function. Okay, so f of x, which is equal to x plus 5, and g of x, which is equal to negative 4x minus 20, are both linear functions. And based on your previous lesson, we know that the domain of a linear function is the set of all real numbers. Okay, so for d sub g is also the set of all real numbers. As mentioned, m of x is equal to x squared minus 4x plus 4. This is under a polynomial function, and specifically this is a quadratic function. Okay, so the domain of the m function is also the set of all real numbers. Okay, so we proceed with the n function. N of x is equal to square root of 2x minus 1. This is an example of a radical function, specifically square root function. Okay, so when we deal with these functions, we consider the radicand, or the terms inside the radical symbol. Okay, so we should look into the value of x. For this example, it's because we are avoiding that the radicand will become a negative number. Okay, so 2x minus 1 must be greater than or equal to 0. So 2x is greater than or equal to 1. Divide 2 on both sides of our inequality. X then is greater than or equal to 1/2. So based on our solution, our domain for the n function is the set of all real numbers greater than or equal to 1/2. Okay. For the two remaining functions, j and p functions, they are under the rational functions. And when we deal with rational functions, we check the denominator. Why do we need to check the denominator? The denominator must not be 0 to make the function defined. Okay, so what we should do is to get values of x, to exclude that value of x in the set of our solution. Okay, so for j of x, which is equal to 2x plus 4 over x minus 2, we just have to equate x minus 2 to 0, and that will be x is equal to 2. So the domain of the j function then is set of all real numbers less than 2 union set of all real numbers greater than 2. Okay, so if we will substitute 2 on our denominator, that will become 0. So on the domain, that means you are excluding 2 on our set of solutions. For p function, okay, we just equate the denominator to 0, x squared minus 25 is equal to 0, x squared is equal to 25, and x is equal to positive negative 5. So we have here two values for x, positive 5 and negative 5. So the domain of P is all set of real numbers, okay, all set of real numbers less than 5. Sorry, that should be negative 5. Union negative 5 until 5. Union all set of real numbers greater than positive 5. Okay, so which means to say that we will exclude negative 5 and positive 5 as the value of x on the denominator of p of x. Let's have our first example under addition of functions. We have here two functions, f and g. F of x is equal to x plus 5, and g of x is equal to negative 4x minus 20. So we are solving for the sum of f and g functions. In your solution, you always start with the definition of the operation. Okay, so for this one, we start with the definition of addition of functions. F plus g of x is equal to f of x plus g of x. Okay, so we just substitute the functions x plus 5 for f of x and negative 4x minus 20 for g of x. Then we combine like terms. X plus negative 4x is negative 3x, and 5 plus negative 20, negative 15. Okay, so negative 3x minus 15 is the sum of f and g functions. For the domain of f plus g, since the domain of each function is the set of real numbers, then the intersection of the two functions or two domains is still the set of all real numbers. So we have here the second example of the two functions g and m. G of x is equal to negative 4x minus 20, and m of x is equal to x squared minus 4x plus 4. So we are solving for the sum of the two functions g and m. So g plus m of x is equal to g of x plus m of x. We substitute the given functions, negative 4x minus 20 for g of x, and x squared minus 4x plus 4 for m of x. Then we combine like terms. The term with the highest exponent is x squared. We just copy it kasi wala po siyang ka-like term. Then negative 4x plus negative 4x is negative 8x. And negative 20 plus 4 is negative 16. So the sum of g of x and m of x is x squared minus 8x minus 16. For the domain of the two functions, d sub g plus m is the intersection of their two domains, and that is the set of all real numbers. So let's have the third example. We have here f of x and n of x. F of x is equal to x plus 5. This is a linear function. And n of x is equal to square root of 2x minus 1. This is a square root function. We get the sum of the two functions f and n. Okay, so f plus n of x is equal to f of x plus n of x. We substitute the functions x plus 5 plus square root of 2x minus 1. Okay? Since we cannot combine these two functions, we just have to copy it. X plus 5 plus square root of 2x minus 1 is the sum of f and n functions. Okay? For the domain of the two functions, that is the intersection of d sub f and d sub n. Okay, so for d sub f, it's the set of all real numbers. For n function, all real numbers greater than or equal to 1/2. Okay, and the intersection then is all real numbers greater than or equal to 1/2 to make our new function defined. Let's solve the next example. F of x, which is equal to x plus 5, and p of x, which is equal to 3x plus 1 over x squared minus 25. So we are to get the sum of f and p functions. Okay, so f plus p of x is equal to f of x plus p of x. We substitute the functions x plus 5 plus 3x plus 1 over x squared minus 25. So we need to get the LCD. For x plus 5, we cannot see any denominator, but it is implied that the denominator is 1. So pag wala po kayong nakikitang denominator sa isang whole number or katulad nitong x plus 5, it is implied that the LCD is 1. Okay? So the LCD is x squared minus 25. So LCD, x squared minus 25, divided by 1 is x squared minus 25 times the numerator, that is x plus 5, times x squared minus 25. Plus the LCD, x squared minus 25, divided by x squared minus 25 is 1 times the numerator 3x plus 1. So plus 3x plus 1 over, we just copy the LCD. Then we multiply the two binomials. And that is x times x squared is x cubed. 5 times x squared is 5x squared. X times negative 25 is negative 25x. And 5 times negative 25 is 125 plus 3x plus 1 over x squared minus 25. We combine like terms, x cubed plus 5x squared minus 22x minus 124 over x squared minus 25. And that is the sum of f and p. Okay, for the domain of f and p, that is the intersection of the domain of d sub f and d sub p. The domain of f is all set of real numbers, while for p, we have set of all real numbers less than negative 5, union of negative 5 and 5, union of 5 a set of all real numbers greater than 5. So we already have this a while ago when we determined all the domains of the 6 functions. Okay, which means the intersection will be all real numbers less than -5, union of -5 and 5, union of all real numbers greater than 5. So which means to say that we will exclude two values which are -5 and 5 as a value of x to the function, to the new function, and of course to p of x. Let's have the fifth example. J of x is equal to 2x plus 4 over x minus 2. This is a rational function. And m of x is equal to x squared minus 4x plus 4, a quadratic function. We solve for j plus m of x. So j plus m of x is equal to j of x plus m of x. We substitute the functions, 2x plus 4 over x minus 2 plus x squared minus 4x plus 4. Okay, we get the LCD, which is x minus 2. Okay, so x minus 2 divided by x minus 2 is 1 times 2x plus 4 is 2x plus 4. LCD divided by 1 as the denominator of x squared minus 4x plus 4 is x minus 2 times the numerator x squared minus 4x plus 4 over the LCD x minus 2. So we multiply these terms. Okay, so we copy first 2x plus 4 plus x squared times x is x cubed, x squared x times negative 4x is negative 4x squared, and x times 4 is 4x. Okay, then we have negative 2 times x squared is negative 2x squared. Negative 2 times negative 4x is positive 8x, and negative 2 times 4 is negative 8. Okay, so we copy the LCD x minus 2. The final answer will be x cubed. We have here negative 4x squared minus 2x is negative 6x squared. 2x plus 4x is 6x plus 8x is 14. 14x. We have 4 minus 8 is negative 4 over the LCD x minus 2. Okay, so that is the sum of j and m of x. For the domain of our functions, okay, so that is a domain of j plus m, we exclude 2 as the value of x on the function j and with the new function formed. Okay, so 2, a set of all real numbers less than 2, union of all real numbers greater than 2. For the last example, under addition of functions, we have here two rational functions, j of x, which is equal to 2x plus 4 over x minus 2, and p of x, which is equal to 3x plus 1 over x squared minus 25. So we solve the sum of the two functions. J plus P of x is equal to J of x plus P of x. For J of x, we have 2x plus 4 over x minus 2. For P of x, we have 3x plus 1 over x squared minus 25. The LCD of the two functions is x minus 2 and x squared minus 25. Okay, so the LCD, x minus 2 and x squared minus 25 divided by x minus 2 is x squared minus 25 times the numerator 2x plus 4 plus the LCD, x minus 2 and x squared minus 25 divided by x squared minus 25 is x minus 2 times the numerator 3x plus 1 over x minus 2 and x squared minus 25. Okay, so we multiply all the binomials. For this part, we have x squared minus 25 and 2x plus 4. So x squared times 2x is 2x cubed. Negative 25 times 2x is negative 50x. X squared times 4 is positive 4x squared. And negative 25 plus 4 is negative 100. Plus, we have here 3x squared minus 2 times 3x is 6x. X times 1 is x. And negative 2 times 1 is negative 2 over x minus 2 over x squared minus 25. We combine like terms. We have 2x cubed, 4x squared plus 3x squared is 7x squared. And for x, we have here negative 50x minus 6x is negative 56x plus x is negative 55x. Then we have negative 100 minus 2 is 102 over, we multiply also the denominator. We have x cubed minus 2x squared minus 25x plus 50. And that is the sum of J and P of x. For the domain of J plus P, okay, for J of x, we exclude 2, and for P of x, we exclude negative 5 and positive 5. So, which means to say, all real numbers less than negative 5. Okay, we have here our number line. Okay, we exclude negative 5, 2, and 5. Okay, so to form the notation, all real numbers less than negative 5, union of negative 5 to 2 and 2, union of 2 and 5, union of all real numbers greater than 5. So that is the domain of J and P.